Welcome to the class. Myself, Dr. T. Prem Kumar, Assistant Professor, Mechanical Department, SRM Madurai College for Engineering and Technology. Today we are going to discuss about the resolution of forces in engineering mechanics. Resolution of forces. First, what is meant by resolution of forces? So the process of splitting up the given forces into a number of components without changing its effect. So, okay, that is called as the resolution of forces. So without changing effect, without changing the force effect, we can split the forces. Okay, so we can split the forces. That is called as the resolution of forces. A forces is generally resolved along two mutually perpendicular direction. So two mutually perpendicular direction means, so example, you can take this force. So this forces is acted at the body. Just imagine the forces is acted at this body. So now the resolution of forces means we can split the forces into two component, two mutually perpendicular direction. So two mutually perpendicular direction is x-axis and y-axis. So if I resolve the forces into x-axis means I can get f of x is equal to f cos theta. If I resolve the forces into y component means f of y is equal to f sin theta. So this is the final formula. Now we derive this formula. I can take this triangle . So cos theta is equal to adjacent side by hypotenuse. So here the adjacent side is f of x. So f of x is adjacent side. The hypotenuse side is f. So adjacent side is f of x divided by hypotenuse is f. So f of x is equal to cross multiply this f into cos theta. So here we derive this formula, f of x is equal to f cos theta. So similarly, a same triangle, so I can take it as sin theta. So sin theta is equal to opposite side by hypotenuse. So here the opposite side is f of y. So f of y divided by hypotenuse is same f. So f of y is equal to f into sin theta. We derive this formula. Okay. So f of x is equal to f cos theta. F of y is equal to f sin theta. Can erase this. In some question, they can give the angle from y-axis, not here. So at that time you can take this triangle, theta, the formula is same, cos theta is equal to adjacent side by hypotenuse. So here the adjacent side is f of y, hypotenuse is f, so f of y divided by f, so f of y is equal to f cos theta. Sin theta is equal to opposite side by hypotenuse. So here the opposite side is f of x. So f of x divided by f. The hypotenuse is f. So f of x is equal to f into sin theta. Okay, so you can note the theta. The theta is given from x-axis or y-axis. So based on this, the formula will be changed. So if theta is given from the x-axis, means the formula is f of x is equal to f cos theta, f of y is equal to f sin theta. If theta is given from the y-axis, means at the time f of x is equal to f sin theta, f of y is equal to f cos theta. So we can see example problem. So this is the problem. 4 forces acted on the bolt as shown in the figure. Determine the resultant of the force on the bolt. So, okay, so using the resolution of forces, you are find the resultant of the forces. See here 4 forces is acted, F1, F2, F3, F4. So first we can draw the free body diagram. So free body diagram, you can mention only the forces. No need to draw this bolt, only mention the forces. 4 forces is acted, F1, F2, F3, F4. Okay. So corresponding angle, 30 degree, 20 degree, 50 degree, this is acted in the axis. So resolution of forces means first you can take 150. If I solve this, means I can convert these forces into x and y component. So f of x is equal to so already we derived that f of x is equal to f cos theta f of x is equal to f cos theta. So here f is 150, cos theta is 30 degree. So similarly f of y is equal to f sin theta. So here f is 150, sin theta is 30 degree. See the tabulation. So magnitude, direction, so quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant, x component, y component. Okay. X component, y component. So for first two forces already I show that how to derive that, 150 cos 30 and 150 sin 30. So both are positive. Why both are positive means both are located, the force is located in the first quadrant. So for that reason, so both will be the positive one. So okay, we resolve the second forces. So second forces is 20 degree from y axis. You can convert that into x axis. 70. The total angle is 90 degree. So 90 minus 20, 70 degree. If I resolve this means the x component is 80 cos 70 and the y is 80 sin 7. Okay. So here the force is located at the second quadrant. So for that reason, so the x component is in the negative side, the y component is in the positive side. So this is in the negative side and this is in the positive side. So similarly we resolve the remaining two forces and we can get minus 110 cos 90 minus 110 sin 90. So here 100 cos 50 minus 100 sin 50. Okay. So if you add this x component and y component means we can get x component 199.1 and y component 14.3. So the formula for resultant is r is equal to root of summation of x square by summation of y square. So already we can find that summation of x and summation of y. So just we can substitute in this formula. So we can get the resultant 199.6 Newton. So similarly, so angle is equal to tan inverse of summation of y divided by summation of x. So xy already we can find that. So just to substitute in this formula means we can get 4.1 degree. So the resultant is located 4.1 degree. So the value is 199.6 Newton. Thank you. So I hope you understand what is meant by resolution of forces. So in the next video we can